So, like I said, guys, this is going to be a very, you create your own way type thing. First thing we got to remember, though, is to verify trig identities, we're going to use these fundamental trig identities. All right, we did these before. You guys should remember those, but if not, we're going to go back through and rewrite these down. Keep this chart with you whenever you're doing a problem, whenever you're doing your homework. Have this page of your notes out, ready to go. All right, you need to be able to refer to them unless you have them memorized, and I'm pretty sure we don't have them all memorized. I don't even have every single one memorized. Okay? All right, so let's go through and fill them out. So reciprocal identities. Top right. All right, so reciprocal identities. What's sine of x equal to? Do we remember? What's the reciprocal of that? Top shelf. Right side. Reciprocal. So what's cosecant, secant? It's paired with cosecant, right? And it's the inverse of it. So it's flipped, right? There we go. 1 over cosecant. Okay, how about cosine of x? 1 over the secant. Tangent is 1 over the cotangent. Okay. And then the next set, they would just be opposites, right? So cosecant, we already said it goes with sine, so it'll be 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent of x. That's nothing new there, right? Okay, quotient identities. I think we talked about these at one point as well. But your tangent is sine of x over cosine of x. What is cotangent then? Cosine over sine. Yep. Cosine x over sine x. All right, those are nothing new. We've already talked about all these. Now, Pythagorean identities, these might, what the heck did those just go? All right, Pythagorean identities, these are probably something a little bit new, but there's 3 of these. So we have the sine squared of x plus the cosine squared of x. That's equal to 1. Okay, the second one we have 1 plus tangent squared of x is equal to the secant squared of x. Then we also have 1 plus cotangent squared of x equals a cosecant squared of x. And now each one of those 3 Pythagorean identities, you can manipulate them a little bit. All right, so here I like the very first one says sine squared of x plus cosine squared of x equals 1. That would also have sine squared of x equals 1 minus the cosine squared of x. Just subtracted back and forth across the equal sign. Okay, basic algebra rules still work. All right, so that is your big list of identities you're going to use. At the bottom, we have some even and odd identities. Again, nothing real crazy, just where that negative goes. Sine's an odd function, so a negative x is the same as a negative out in front of the sign. Cosine is an even function, so a negative x is the same as just x. All right, so why did I go over all these? Well, what we're going to do is going to use these to verify other identities. So the fundamental trigonometric identities are used to establish other relationships among trig functions. To verify an identity, we show that one side of the identity can be simplified so that it's identical to the other side. So it's like a puzzle or a game. All right. It's going to take a little bit. I'll be honest with you. It's going to take a little bit for you guys to get good at these, to feel comfortable with these. So I would not be shocked if we don't leave this lesson this week. Okay, it's probably going to be 2 days to go through it, but then we're just gonna do a lot of practice. Okay, so it's like a puzzle or a game. Try something. Sometimes it doesn't work. Try something else. It's like a map. Like I said, you have your starting point, you have your ending point. You have to find the turns along the way. You have to find out which route you're going to take first, which route you're going to turn onto, those types of things. Now, I'm going to give you a basis here. I'm going to give you some notes to go off of, just kind of an overall outline of tips to use. And this is where people kind of struggle a little bit with this. It's because it's not step 1, step 2, step 3, step 4. These are things to try. Okay? So What you want to do, you want to work with each side independently. You want to start with the more complicated side. Typically, when we have an equal sign, what do? We take things from one side to the other, right? We are not going to do that in this one. All right? We are going to put a line down the middle and basically have two columns. Okay? Nothing crosses the equal sign. Second thing, want to analyze the identity and look for opportunities to apply fundamental identities. So if you have something like a cosecant, well, if we have a cosecant, then we can replace cosecant with what? 1 over sine of x. All right, we'll do things like that. We're going to look to replace. Okay, so then here's the good techniques. First, rewrite the more complicated side. If you get it into terms of sine and cosine, that's going to be your best avenue. If you look back here at the beginning, you see sine and cosine probably more often than any of the words up here, right? So we get stuff into sine and cosine, we can work with it. Second thing, you want to factor out GCFs, or if you have sine of x plus cosine of x times the sine of x, you can factor out a sine of x, for instance. Separate single term quotients into two terms. So if you have two things on top of a fraction and one on the bottom, you can split it. If you can combine fractional expressions using your least common denominator, we did those back in intermediate algebra and college algebra. Multiply the numerator and the denominator by a binomial that appears on the other side of the identity. We can multiply by conjugates, those types of things. And the big thing, another thing, just don't be afraid to stop and start over again. You're going to get to some point at somewhere and be like, man, I can't do anything else with this. What the heck do I do now? Starting over is not the worst thing. Okay? So we're going to do a bunch of these. I mean, look at my notes up here. 3 of these, 2 of these, 2 of these, here and here. And as you'll see, I mean, I'm not going to lie to you. Some of those are kind of long. Okay? It's a process. With this, I'm not going to give you 25 problems for homework either. You might have 5 or 6. You know what I mean? So, here we go. Ready to try it? Who's excited? Thanks. Thank you. Wilson, fresh off that 100% on that test, huh? You're still feeling good about Trig, aren't you? All right. Then we hit today. All right, so first one, changing sines and cosines to verify an identity. So I'm going to start here, and I'm going to give this. Secant of x times the cotangent of x is equal to the cosecant of x. So what we want to do, we want to verify this. We want to verify that the secant of x times the cotangent of x is actually equal to the cosecant of x. Okay? We don't have an identity that says that, right? What's the identity for the cosecant of x? If you look back, what is it? 1 over sine of x. Well, this is obviously different than 1 over the sine of x, right? So we need to take this and manipulate it around to see if we can make both sides equal the same thing. So what I like to do with these, I wrote the problem down. I'm going to put a big bar down the middle. So I don't ever try to take things back and forth. All right? Now I want to take the more complicated side. The more complicated side here would be the secant of x and cotangent of x. And I want to make this side, I want to manipulate it to make it say cosecant of x. All right? So in your head, what can we be thinking? Well, we already saw cosecant was 1 over cosine, right? Or sorry, 1 over sine. So if we can get a 1 over sine, that's the same thing, right? Let's try to get some secant and cotangent. Can we rewrite those as sines and cosines somehow? Yeah. All right. So what's the secant of x? What's that equal to? 1 over cosine. All right. Let's go ahead and replace that. So I'm going to say the secant of x is actually 1 over the cosine of x. The cotangent. What can I rewrite the cotangent as? It could be 1 over the tangent, but I'm already thinking cosine here, right? Cosine and sines. Is there a relationship for cotangent that has sine and cosine? Quotient identities, right? Cotangent is equal to cosine of x over sine of x. Okay? So I just replace this, get this, and like I said, get it to sine and cosine if possible. Now I'm multiplying two fractions. What's something you see there? Cosine you cross out, right? Give it a little shoo, shoo, right? So now I'm left with 1 over the sine of x. What's 1 over the sine of x equal to? Cosecant of x. Did I just verify this? Yes, I did. So after I make that line to split it, if I have both sides the same, I like to put a nice big check. That means I verified. I'm done. So I did replace, kind of manipulate a little bit, and made them show them both as the same. Questions on that one? With me, all right? Okay. I want you guys to try one here. I'm going to give the cosecant of x times tangent of x is equal to the secant of x. I'll go ahead and split it for you. Manipulate that left side using your identities. So, cosecant and tangent. Let's rewrite them. What am I going to rewrite those as? 1 over sine of x times sine of x over cosine of x. Then what? Cross out the sines. Left with 1 over cosine of x. 1 over cosine of x is the secant of x. Boom. Done. And like I said, on the first one, remember I said on the first one, 1 over the sine of x? When I think cosecant, I think 1 over sine of x. I did look over, I saw her paper. That was the first thing you did, wasn't it? You looked at this and went, all right, I'm going to manipulate this side, but I'm going to write this as 1 over cosine. Just give me something in mind. All right, that's like knowing that your friend's house is right behind McDonald's. You know what I mean? You see the steps when you're almost there. All right, back to that roadmap mentality. All right, let's do one more with this style, this first style, and then we'll go from there. Run out of room. Guess I have this written down in case if I erase it. You good? Okay. All right, so this next one, we're stepping up just a little bit. And I mean, this one here that we just did, this would be like a level 1 problem. All right, this is level 1, maybe 1.5, and we'll just kind of keep building from there. And each one of those different techniques up here, these 5 here, we're just going to do some of each type. Some we're rewriting with the cosine and sine. Some will refactor out of GCF and so on. Okay, just so you've seen it every which way. All right, so we're going to go sine of x times the tangent of x plus the cosine of x equals the secant of x. Splitter. All right, so just like the last one, I'm equal to the secant of x. So probably 1 over cosine is my next to last step, right? All right, now looking at this thing, I already have a sine and a cosine, and I want to try to get things in sine and cosine as much as possible, typically. So let's rewrite that tangent. What's that tangent going to rewrite to? Sine over cosine, right? Okay. I'm just going to leave the other ones as is, because I like sine and cosine the best. All right, now what's sine times sine? Sine squared. So I got sine squared of x over cosine of x plus cosine of x. All right, so now I introduced cosine and sine. Now I also have a fraction too, don't I? So right now I'm kind of stuck, right? But now I see a sine squared of x. All right, sine squared of x. Anytime you see sine squared of x or cosine squared of x, that reminds me of that Pythagorean identity. Okay, so maybe there's an avenue for us at some point. And I have a fraction in a single term. Let's write this as one fraction. Combine with common denominator. Want to try that? What would your common denominator be for these two? Cosine of x. All right, so in this case, this guy would be over 1. So my common denominator would be cosine of x. So I need to multiply this guy by cosine of x over cosine of x. That's going to help me combine those 1 and 2. I'm going to get a cosine squared on top, aren't I? Oh, yeah. You could, but you don't want to. You really don't want to. You want to manipulate one side if at all possible. You only want to manipulate both sides if you get stuck on one side. All right. All right, so there we go. We got sine squared of x plus, this would be cosine squared of x over cosine of x. Now I have my common denominator, right? Now that's going to give me sine squared of x plus cosine squared of x over cosine of x. Well, we just said, what's sine squared of x plus cosine squared of x equal to? 1 over cosine of x. 1 over the cosine of x is what? Secant of x. Boom, done. Well, doesn't that sound satisfying? Doesn't it feel satisfying at the end? Did I lie to you, though? I told you a lot of people don't enjoy them. Sine squared of x plus cosine squared of x, it's one of the Pythagorean identities, and it's equal to 1. So I replace sine squared plus cosine squared with 1. It's the first of the 3 Pythagorean identities. All right, there we go. That was writing stuff in times in cosine and sine, those types of things. Questions so far? You see what we're doing? Okay. Question? Someone just say it was fun. All right. Cope, we know you won't be in that place. Or cry yourself to sleep because of homework. All right, so let's just do some using some factoring. Okay? What if we have to factor sometimes? What? Just do it. It's like Nike. Just do it. All right, so cosine of x minus the cosine of x times the sine squared of x is equal to the cosine cubed of x. Oh, yeah. Let's split that guy. What's the point of this is to show that just because something isn't a cosine or sine, and there's just one, like we have this. We just did a whole chapter with it. Really? Really? Now, hold on a second. Hold on a second. Now, now, the reason that we use these, the reason that we're identifying is to show that there is way more combinations of things that will work for different scenarios than just this. This is the very base of these, okay? We're going to be using more of those going forward, okay? Now, let me tell you a little story here. Okay, so looking at this next problem, cosine x minus cosine x sine squared x equals cosine cubed of x. So we want to verify that those two are the same, okay? Obviously, we want to do the side that's uglier, which is the left side, right? All right, now looking at that, what do you see in both of those first two terms? You got a cosine. Let's factor that guy out. So cosine x, 1 minus sine squared of x. Agreed? Now, sine squared of x. Remember I said sine squared, cosine squared? That makes you start thinking that Pythagorean identity, right? What's the Pythagorean identity say? Sine squared plus cosine squared is equal to 1. Now, in this case, I have 1 minus the sine squared of x. What would that be equal to? Cosine squared of x. So let's replace. What's cosine times cosine squared? Cosine cubed. Boom. That was kind of easy, huh? Okay, let's try that second one. I thought you were volunteering. We got a volunteer here, anybody? Anna, you think these are fun? Why don't you tell us what to do? What did you do first? Okay. Uh huh. Good. Good. How many of you guys got that? Okay. Let's look back here at your trig or Pythagorean identities, right? I have sine squared of x plus cosine squared of x equals 1. I can subtract 1 from the other side. I can subtract cosine squared over. I can get 1 minus the cosine squared. I can manipulate any of those three. Okay? I can say that sine squared of x minus the tangent squared of x is equal to 1. Okay? Those three are kind of the special ones that you can take those and you can manipulate those just using algebraic terms. All right, let's do one more today. Okay? So this one is using two techniques to verify. So we're actually going to do this one problem twice. Okay? And again, this is going to be one of those ones where you can have 2, 3, 4 different varieties and ways to do this, but still have the right answer. All right, so we're going to go 1 plus sine of theta over cosine of theta. We want to verify that's equal to secant of theta plus the tangent of theta. All right, so look at this right now. And we're going to do this two ways for a reason. So this will be way 1. Then way 2 will be the same problem again. Over cosine of theta equals the secant of theta plus tangent of theta. And the reason I'm going to do this twice is because, say, Maurer over here thinks, all right, that left side looks more confusing to me, and it looks more difficult because there's a fraction. Okay, then Barron's over here going, no, it's definitely because of the secant square, or the secant of theta and tangent of theta. So you could very well, half of you think the left side is the one to manipulate, and half of you think the right side is the one to manipulate. All right, so we're going to do this two ways. to show that we can get the same thing both ways. All right, so let's do the left side on method one. First thing I see this fraction here, and there's nothing I can really do. Okay, I got sine and cosine. If I could somehow get rid of that 1, then I can rewrite it as a tangent. And that gets me to here, right? So let's split the fraction. Is that what you're thinking, Solid Mullet? Okay. Wouldn't that be the same as 1 over the cosine of theta plus sine of theta over cosine of theta? Absolutely. All right, it's still the same bottom. All right, it's the reverse of adding things with the same denominator. Well, what's 1 over the cosine of theta? Secant. What's sine over cosine? Tangent. Am I done? No. I just verified it.
Wow, that was so easy.
Now, let's go in the other direction. So that was Maurer up here. She said, I want to do the left side. She's done. She got a right answer. Now Barron's going, no, we got to take care of this right side. She's being stubborn about it. Okay? So let's rewrite using the right side. Just go in the opposite direction. What's secant equal to? 1 over cosine. What's tangent equal to? There we go. We have a common denominator here. Yes, we do. 1 plus the sine of theta over cosine theta. Boom. We just did it reverse order. Okay? I didn't say that was harder. All right. So here is the one we're going to do. Any questions on this first off? All right. I'm just going to write this up here. This is where we're starting tomorrow. Cosine x over 1 plus the sine of x plus 1 plus the sine of x over cosine of x equal to 2 times the secant x. That's where we're going tomorrow. Okay, we'll stop right there.